welcomes you all. We are going to discuss cam and follower. Cams. Cams are used to convert rotary motion to oscillatory motion or oscillatory motion to rotary motion. For high-speed applications, example internal combustion engines. Main objectives of this chapter: learn fundamental concept and terminology, learn how to design a cam and follower set to achieve a desired output motion. This is the example for cam. An IC engine to operate the inlet and exhaust valve. Classification of cam mechanism. Based on modes of input-output motion. 1. Rotating cam, translating follower. Number 2. Rotating cam, oscillating follower. Number 3. Translating cam, translating follower. These figures clearly represent rotating cam, translating follower. The purple color is the cam and the top, the round shape, the blue color is the follower. Number 2. Rotating cam, oscillating follower. The figure clearly shows the cam and follower. The larger diameter is the cam and the smaller diameter is the follower. Number 3. Translating cam, translating follower. The figure clearly shows the translating cam and the small diameter round shape is called as translating follower. Classification of cams: A. Radial or disc cam. B. Cylindrical cam. C. End cam. The figure A, B, C, D shows the radial or disc cam. In radial cams, the follower reciprocates or oscillates in a direction perpendicular to the cam axis. In cylindrical cams, the follower reciprocates or oscillates in a direction parallel to the cam axis. End cam. It is also similar to cylindrical cam, but the follower makes contact at periphery of the cam as shown in figure. Thank you.